Okay, so this is the problem that I was given to present for presentation 4. So the eigenvalue is 2, and the corresponding vector is -1 and 2. And for our second eigenvalue is -2, and our eigenvector is -1 and 1. So the diagonal would just be the eigenvalues that we were given, diagonalized. So we'll put 2 here, and 0, 0, and -2 diagonally. For our P matrix, is going to be the eigenvector -1 and 2, and put that on the first column, and our eigenvector for the second value, -1 and 1. Now to find the inverse of this, we will get a second matrix next to it, where we put 1, 0, 0, 1, and then we get the reduced row echelon form for this. So I did the steps on this side of the page, but for this we got the values that were given here, and we will just use this part as our P inverse. So 1, 1, -1, -2, and -1 will be our P inverse. Now to get the matrix, we use these values. So P is our value here, then we get our diagonal and our inverse. After that, we want to multiply all of them. So first we can either multiply the first two or the second two. I did the second two because that's how it was done in the example on the notes. So we did the first row times the first column. That's gonna give us 2, and -2 times 2. We get 2, and then -2 times 4. -2 times -2 is gonna give us 4. And -2 times 1 is gonna give us, because we have a 0, gonna give us +2. After that, we want to bring down the P, our P matrix, and multiply that. So we do the -1 times -2 times 2. That's gonna give us -2, -1 times 4, gonna give us -4, and that's gonna give us 6. Then -1 times 2, and then -1 times 2 is going to give us -4. For the bottom row, 2 times 8, 2 times 4, 2 times 2 is going to give us 4, then 1 times 4 is going to give us 4, 2, 4, and then 1 times 2 gives 8, and 2 times 4 is going to give us 2 times 2 is going to give us 4, and then 1 times the second row, 2 times 2 is going to give us 4, and then 1 times 2 is going to give us 2. Adding together, that's going to give us 6, and that will be our matrix A. And that's how we get the matrix A with the eigenvalues and the given vectors, eigenvectors. Thank you.